Hello programmers, welcome to the video. So today we will be solving day 13, 13th of October problem. So today's problem is find resultant array after removing anagrams. Okay, let's directly jump into the problem. So question is given, find resultant array after removing anagrams. It's an easy question and nothing like yesterday is hard. Yesterday was a challenging questions. Okay, so let's read this question out quickly and let's directly jump forward. Okay, so you are given a zero index string words, so we have a string of words, okay, where words I consists of lowercase English letters. In one operation, select any index I can select any index I such that I is 0 to word dot length. Okay, so what's the range of I? Minimum greater than 0 means 1 to word dot length, let's make it n, so it's n minus 1. Okay, this is the range we have to operate in, and words of I minus 1 and words of I. Okay, that's why they need this from 1, because words of I minus 1 will be 0 if I will choose I equal to 1. Okay, so previous index and words of I current one are anagrams. Okay, select any index with I this and words I this anagrams, delete words I from words. Okay, so if we have two words a comma the word 1 comma word 2 comma word 3 dot dot dot, and if we choose this word I, this is I minus 1 previous one, if both of them are anagram I will delete this from array. Okay, keep performing this operation as long as you can select an index that satisfies condition. So we will keep going ahead, and I will like this after deletion the next one will become like I. Okay, this is I, then it will again become I minus 1. If it is a anagram I will delete. Same way I will keep going until I find a word which is not anagram. I just have to check the previous one. And check if it is anagram or not. So here the definition of anagram is also given. Anagram is a word or phrase formed by rearranging the letters of different word or phrase using all the original letters exactly once. So for example, D A C B is an anagram of A B D C, because all these letters like A comes once, B C D, and here also all the letters comes at the same frequency, just we are rearranging the letters and we are forming new words. This is called anagrams. Okay, and after all what I want to return, we have to return the written words after performing all operations. It can be shown that selecting an indices is performance any arbitrary order will lead to some result. Yeah, it is saying that after performing this operation on an array we have some resulting array, and this resulting array we have to return this resulting array. Correct? Okay, so let's understand this better with an example. I will clear all my drawings. Okay, so here example number 2 is smaller, given it's like A B C D E. Okay, so all the letters are different, there is no anagrams can be found, so this is the output. So no two adjacent strings in words are anagram for each other, so no operations are performed here. Okay, let's understand the example number 1. Let me change the color. Okay, so we will find that we have a B B A, this is our zeroth word. Okay, then we will come at B A B A, this is our first word. Is it same as previous? Yes, I will delete this. I treat it like I don't have this. I haven't seen this. Now next word comes as B B A A. Okay, is it anagram to this? The previous word is this. This is deleted. After deletion, this is the previous word. Is it the same anagram? Yes, because 2 frequency of A and 2 frequency of B. I will delete this. Now next one is C D. Is it same? Is it anagram to previous one? Is it anagram? No. So I will keep this. I will keep the first word always, like 0th word always. Then I will keep this CD. Next word is CD. I will check just before that. I will not check AA. I will just check just before the this index, previous one, and I will check. Okay, this is basically similar thing. This is anagram. So I will delete this. At the result, I will have this ABBA and CD. Okay, in order ABBA and CD, and we have this array, resulting array. Okay, fair. How to find a? So there is two things. One, we have to iterate. and we will keep storing different words in a resulting vector. So I will make a vector of strings basically, and I will store all my result in that. I will keep storing, but to find an anagram, like this word and this word is anagram, what to do? It's simply like we can sort this array, so it will be like AABB, and I will sort this array as well, so it will also become AABB. And if both of the strings after sorting is the same, then we can say it's a anagram. Okay, it's a anagram. But after sorting, we don't have to store this sorted vector, sorted string in this vector. I have to store this original one, original word. So I will keep this in some temporary variable and then sort it. I will directly not sort my words. I will not hamper my input here. Okay. So I hope you understood this concept. It's a very easy problem, easy kind of problem. So let's directly jump into the code and quickly code it. You will get more clarity if you are not till now. So let's take size of words as n, and we have constraint that we have at least one word in the length. So words of I is there. Okay, so constraint is very relaxed, I think so. Yeah, so we have word size. Okay, I will check, I will keep my like some previous word, string previous word in words of 0. So I will take previous word as words of 0, and I will keep kept in that. Okay, and I will obviously sort this word. So I will find anagram previous dot begin comma previous dot end. So I am sorting this word as well. Now I am looping through int I equal to 1, I less than n, I plus plus. If so, let's say int string of current word, string current word is words of I. Okay, I have a current word. I will sort this as well. Sort of current word dot begin, current word dot end, and okay. And if I check if my previous word is not equal to my current word, then I will push my current back to a resultant vector. Okay, so let me make a resultant vector, string result. Okay, and I will push my first word obviously, result dot push back words of 0, because it's always unique. Words of 0, the first element I have pushed it, and I will push this word as well, result dot push back. So what I will do, I will do this result dot push back this word of I. Okay, this current word I will push, not the sorted one, and also I will update my previous vector to this current word, previous word to this current word. That's it. At the end we will return our result vector. I think it will work. Let's check. It's accepted, both the cases are passed. Let's submit it, and it's accepted. Okay, so now we have 16 days free. Good, great. So let me explain you the time and space complexity of this problem. Okay, so in the interview it is asked, we are storing result in the resultant vector, so space complexity can be like big of n. Okay, this is our space complexity, big of n, and if I am not considering this result vector, then it will be like space complexity of big of 1 extra, basically extra space. We are not taking any extra space out apart from this resultant vector. Okay, what about the time complexity? At the time complexity level, we are sorting some things, so we are sorting each words one time, at least one time. Okay, and we are looping through this number of words, so it will be number of words, which is n multiplied by the sorting algorithm will take m log m time, m log m, where m is the number of letters, so n is the length and m is the letters. So later लिख देता हूँ, okay, later log later, something like this. Okay, this is our time complexity. So if you see, we have in constraints we have this letter length is 10 only, so it will be like 10 log 10, 10 log 10. So I can make it like constant. If it is constant, then it will become supposed to be the total length of this array of words. Correct? Great. So I hope you understood this problem and the solution. Let's meet tomorrow. It's an easy question for today. Let's hope we will get a good question tomorrow.